So hello everyone and welcome to today's webinar, Analytics for New Construction and Ongoing Commissioning. This presentation is being brought to you by CopperTree Analytics and sponsored by the Western Canada Chapter of the Building Commissioning Association. My name is Jesse Securo. I'll be the moderator for today's presentation and just have a couple items for housekeeping before we get started here. Please note that throughout the presentation, all microphones will be muted to minimize any background noise or feedback that may distract from the presentation. We'll be using the Q&A function for questions. So at the bottom of your screen, if you have any questions, please use the Q&A button. Provide your question there, and we'll have a period of time at the end of the session today to address those questions. Today's webinar will be recorded and available for future reference. Our presenters today are Derek Molasseri and Michael O'Brien. Derek has been with CopperTree since 2014 and has managed several projects in the commercial real estate, government, education, and healthcare sectors. He has a background in engineering, and his interests include data analytics for building performance improvement, controls optimization, energy management, and behavioral change programs for occupants and operators. Michael joined CopperTree in 2020, bringing with him nearly 20 years of experience working in the construction and building automation industry. He has held previous roles, including controls technologist, project manager, and facilities operations coordinator. Michael is a strong advocate for utilizing new technologies, including building analytics, to enable ongoing improvements in building optimization and performance. Really looking forward to today's session and want to say thank you, Derek and Michael. The show is yours.
Thank you, Jesse. Appreciate it. Welcome to this webinar on analytics for new construction and ongoing commissioning. Our focus today really is to talk to you about how analytics can help you in your commissioning requirements. Before we get going, I'd like to take a minute to introduce CopperTree Analytics. CopperTree is the developer of Kaizen, a powerful analytics software with a patented algorithm using artificial intelligence to translate your building's data into useful information. Our product, Kaizen, continuously acquires data from buildings, monitors system performance and energy consumption, and it analyzes equipment operation to detect faults and anomalies. CopperTree came into existence in the year 2011, 2012. From then, we've been working in this industry, working with a lot of partners and customers from around the world. We currently have about 2,000 buildings in our platform. It is although in the last 2 years or so that we really began working more and more closely with commissioning agents. And we can now see a change in direction, a change in trend really, where not just are we focusing on building operators and facility managers who are using buildings that are fully occupied. We have the product being used extensively for new construction commissioning and ongoing commissioning. And that's what we're going to be presenting on today. How can analytics be useful for those requirements? So the agenda is to begin with the commissioning process. I know that a lot of you listening to this webinar are professionals in this field, and I don't need to introduce the commissioning process to you, but we'll be looking at a few slides just to connect the commissioning process with the analytics reporting tool that we have. We'll then talk about new construction commissioning and the role of analytics in new construction commissioning. We'll discuss the opportunities for ongoing commissioning and wrap up with a Q&A period. Now, in terms of learning objectives, at the end of this presentation, I'm hoping that we'll be able to highlight the value of continuous data in new and existing building commissioning. Note that I'm saying continuous data, so it's not a one-time export from a building automation system and doing some analysis on that export. We're talking about a continuous stream of data flowing out from your buildings into cloud servers, where analytics engines are able to grind through that data and generate useful information. We also want to demonstrate through very practical examples how analytics can enhance new building commissioning. We have a few slides that are dedicated to real-world examples that we are really excited to share with you. And we also want to recognize the opportunity for ongoing services in existing building commissioning. And that's a topic I believe some of you may be already familiar with, but we'll look at it at a different perspective today. Now, the commissioning process itself. This recently released ASHRAE guidelines document, it talks about the commissioning process as a quality-focused process for enhancing the delivery of a project by achieving, validating, and documenting the performance of facility elements in meeting the owner's objectives and criteria. See that it's talking about a quality-focused process. Now, this slide shows an excerpt from the document, A Guide to Building Commissioning, which was released by Pacific Northwest National Laboratory based in Washington. It talks about building commissioning as not just an energy saving strategy, that it is, again, note, a quality control process, and that commissioning can also be considered as a risk management strategy. And on the right-hand side of the screen, you can see the different phases involved in a commissioning project. We have design, we have construction, we have operations. And for each of these phases, there is much planning that happens. The plans are then executed. After the execution is complete, during it and after it, you have to check how well things were executed. And when you do that check, obviously you're going to generate findings from it on which you need to act on. And that cycle continues. So it's not a one-time process where you have a planning, a doing, a checking, and an acting. Rather, it's an ongoing process, which is a risk management strategy and a quality control process. Now, this slide here, all of you may be super familiar with this. It comes from the BCxA Association, the document titled, What is Building Commissioning? Again, it talks about the quality assurance process and talks about perpetual benefits, beginning with a more efficient collaborative design and construction process, and that it continues throughout the life of the building. See, again, we're talking about the design phase, construction phase, and it continuing throughout the life of the building. Now, before we go deep into analytics and how it can assist with commissioning requirements, I wanted to talk about some of the very common buzzwords, keywords that we often hear in the industry. We hear EMIS, EIS, FDD, BAS, and sometimes it's also interlinked that we don't differentiate it well enough. An energy management and information system comprised of hardware and software products. It's a broad family of tools and services to manage commercial building energy use. So the big umbrella, so to speak, is the energy management and information system. Under that umbrella, you have building automation system, the BAS, which we are very familiar with. And then there is FDD, which is Fault Detection and Diagnostics. Now, if you are thinking of using analytics for your commissioning requirements, you need to make sure that the analytics platform is not just an FDD platform, that it also has an EIS component to it, Energy Information System. So EIS platform plus the FDD platform and your building automation system makes up the EMIS system. We'll talk about what an FDD platform is and what EIS does later on in the presentation. For now, keep in mind that a good analytics tool will allow you to not just detect faults, but also assist you with tracking energy consumption, measuring and verifying changes that are happening in the building, and it also provides you with energy reporting. Data acquisition and analytics infrastructure. This slide here shows you a building automation system network. You can see the networking, you can see the parent controllers and the child controllers. Your BAS is connected to the HVAC equipment, but it doesn't need just be HVAC. You can have auxiliary equipment. You can have escalators and elevators connected to it. You can have gates at an airport connected to the building automation system. All of these different systems generate data. And what we need is that data to be collected. So for CopperTree, we use the edge device. And for other analytics vendors out there, they have similar devices that are used to collect data from the building automation system. The on-site devices acquire and deliver data to the cloud infrastructure. You can see that the data goes through the firewall into the analytics server. Once it reaches the analytics engine, we examine the data sets to generate reports and send notifications by email. And this is a piece perhaps we may talk about more in the Q&A session, because this is super critical in the process, and that continuous stream of data is what really makes an analytics tool smart. Now, let's talk about new construction commissioning and the role of analytics. We'll discuss the different phases in new construction commissioning, challenges that we often see, and some findings. We'll talk about analytics being used for measuring, validating, and sustaining different items. With that, over to you, Michael.
Thank you, Derek. So we'll begin with the building commissioning phases. Most will agree that these are the three major phases in new construction commissioning: the design phase, construction phase, and operations phase. And in each of these phases, the role of an analytics platform is different. During the design phase, measuring, which includes questions revolving around data. During the construction phase, validating or verification is to be complete. And during the operations phase, sustaining or maintaining, which may include benchmarks and various performance metrics. Here are some of the challenges with building commissioning that you may be familiar with: poor planning, timing issues with various trades and vendors, equipment not being ready, lack of metrics to measure operational performance, site, floor, equipment is filthy, or the BAS is inaccessible on-site or remote. Can analytics help overcome one or more of these? Yes, with the exception, of course, of the site and equipment being filthy. There isn't very much we can do to help you there. And here are some of the findings that you'll likely come across as the commissioning process unfolds. There are BAS network controller issues, systems operating outside of schedule, set point settings outside expected parameters or lacking reset strategies, control loops performing poorly, either sluggish or unstable, control sequences not as designed, or sensors, control devices malfunctioning and or mislabeled. So how can analytics help? It can identify control sequence issues, detect installation issues and equipment device faults, measure performance, report non-compliance, which may include occupancy safety and comfort, energy use intensity, process monitoring and control, and as of recent, it may now include any COVID-19 measures that have been put in place, such as increased airflow or revised equipment scheduling. Central to the commissioning requirements for the design phase is the development of the functional testing scope for each system or piece of equipment. And since trend logs are essential to the verification of system functionality, there needs to be a validation process to make sure all inputs, outputs, set points, and other variables are being trended accurately. This will help to confirm proper operation of all major control loops, equipment staging, and time of day scheduling. Design phase, organization and identification. During the design phase and just before the next phase, when functional verification begins, there is the need to first identify the point function, secondly, organize the building automation system points into systems. At this stage, data organized into systems is fundamental to the functional verification of systems, which are groupings of pieces of equipment with sensors and control devices. Since the system graphics aren't typically available at this stage of the project, analytics can really help to bring the HVAC system into perspective. Now first, back to the data sources. Trend logs at the edge are those that exist within the BAS. These are created and set up inside field-level controllers and network devices. Extracting these trend logs and sending them to a central repository or cloud infrastructure is the job of an edge device. You can see here on the left some standard objects that we'd expect to find trended for an air handling unit, and on the right, we can see their properties listed. Trend logs at the cloud, on the other hand, are not created in the BAS controllers. Rather, edge devices capture data points and their values from BAS controllers and create trend logs at the cloud, where they can then be visualized and processed by analytic engines. The BAS points or objects, along with their various properties and values, can also be captured by edge devices and shipped to the cloud. Our analytics platform Kaizen then becomes a historical database for each system point. Some valuable properties can include point value, units, out of service, calibration, and commission and decommission flags. One critical aspect of measuring is systems organization. This visualization of the systems view within Kaizen is showing not a flat list of systems, but a hierarchical system structure that helps to view a system as one entity with various components while understanding how each system is interrelated with other systems in the building. In this example, we can see that under the systems view, when we select ventilation, all of the HVAC equipment related to air ventilation is displayed within the drop-down menu. Systems groups, such as FCUs or fan coil units, can then be selected to display various types of metrics, such as KPI scores, which are shown on the right. Point identification. In regards to this topic, how many of you have been frustrated with a BAS point naming convention or lack of a standardized naming convention? Using tags is a way to solve this problem while also providing many other advantages. Shown here is a fan coil unit with all corresponding sensor and control points, all tagged using a combination of haystack and custom tags. You can see the equipment name, FC_01, in the top left, which has 3 system tags applied to it. And just to the right of that, you'll see all of its subordinates, which are the fan coil unit equipment points. These control points are all assigned tags using our tagging tool, which allows us to quickly streamline this process. The value of tagging. These tags are like the glue that tie in the analytic rules that exist in our community library. Our analytics platform Kaizen will do the tedious work of finding the systems that have the required inputs by matching the tags in each rule and then creating an instance of that rule. This works when the systems in a building have been properly tagged. This example is showing the tags associated with a discharge air temperature sensor and how our rules are set up to identify these tags. We can see the text shown in light blue for our SAT, or supply air temperature sensor. To the right of that, within the blue boxes, you'll see the tags that have been applied to this sensor, which include air, analog, discharge, sensor, and temp. The function of this particular rule is to identify if a discharge air temperature sensor may be faulty, and therefore a rule will be applied to all discharge air temperature sensors within the building that include these tags. There are, of course, other benefits to tagging, but we'll leave it at this for now. Now moving on to the construction phase, commissioning activities. The focus here are the functional tests, and one of the key questions everyone involved in commissioning asks is, are we ready to do a functional test on System A or System B? How can we confirm functional test readiness with the use of analytics? The coordination, execution, and documentation of functional testing represents the bulk of the activities in this phase. This includes testing and retesting in accordance with specifications, deferring testing to the next phase as required, so that tests are performed during proper weather or operating conditions, and once again, trend logs, which are essential in confirming proper system operation. These trend logs typically include temperature, flow, current, status, pressure, set points, etc., which are all utilized to confirm proper system operation over time. Compile the construction phase commissioning report, which includes all of the previous activities leading up to this point. The commissioning report will include evaluation of operating condition of each system upon completion of functional tests, deficiencies list and status, deferred functional testing description and schedule, and commissioning specifications, field reports, checklists, startup reports, etc. The construction phase, functional testing and reporting. So how can analytics help in this phase? We'll go over a few examples on how trend analysis can help provide the basis for commissioning reporting. Analytics on demand, system scheduling. So here's an example from a real site of an incorrect schedule programmed for a fan, causing it to run 24/7. When we look at our TL viewer, you'll notice that prior to November 10th, the fan was scheduled to run 24/7. That's our pink line, which represents the time schedule command for this particular fan. The red and blue lines represent our fan command and fan status. The rules applied within Kaizen will detect these anomalies and bring them to our attention so that corrective action can be done. You can see in this example that the proper time of day schedule was applied on November 11th, and thereafter the fan command and status points began to cycle on and off. One of the benefits using an analytics platform is visibility of multiple systems, regardless of which BAS device is controlling them. Here's an example showing 21 trend logs from primary fan systems. We have selected the supply fan status points for each air handling unit and makeup air unit. In the upper right corner, we have the ability to select different date ranges to show a day, week, month, or year. In this example, we are looking at a 10-day period starting on April 11th. We also have the option to favorite or save this page so that it can be quickly accessible at any time during the commissioning process. With this type of view, finding anomalies or systems deviating from the norm is often an easier process. In this example, we're using the same group of systems from the previous slide. You'll notice when looking through our supply fan status points, we can quickly determine a normal operation pattern and also detect any outliers. In this case, we can see that the two fan status points for MAU1 have both been running from April 13th onwards. This leads to the question, why is MAU1 running when the building isn't occupied? So, can we use analytics to further investigate the continuous operation of MAU1? The answer is yes. Let's start with the historical record and look at the supply fan operation since January 2020. We've now pulled up more than a year's worth of data, and we can quickly see that MAU1 doesn't necessarily always run 24/7, but there have been periods when it has. In this case, we can see that the fans have been running continuously since the beginning of March till the end of June. From here, we can further drill into this time frame to better determine why the fans were always running. We can also display additional data points that we know are relevant to this unit and that will assist us in identifying the cause of this fault. We'll continue on with this example on the next slide. As commissioning professionals, you know and understand the sequence of operation for each type of building system. So in this case, you likely already know that MAU1 is interlocked with various kitchen exhaust fans. As shown on the left, by simply running a quick search for KEF and by selecting and displaying the 9 kitchen exhaust fans, we can determine yet another important piece of information. The trend log view on the right shows all of the selected exhaust fans served by MAU1 and how their individual frequency values fluctuate. You'll notice, however, that for some reason, KEF8, which is shown in purple, has remained on while the building was unoccupied. Knowing that the makeup air unit is interlocked with the kitchen exhaust fans, we've now identified the reason why the fans were running continuously during this period of time. To validate this, we can simply select a date range when MAU1 was operating as per the time of day schedule and confirm that kitchen exhaust fan 8 was also being disabled. Let's move on to another example. This slide shows 2 examples of airflow issues identified through on-demand analytics. For both examples, we're looking at air volume set point, which is shown in red, and our airflow sensor, which is shown in blue. For the trend view on the left, we found that the airflow set point was manually overridden and was greater than the maximum CFM. You can see when the correction was made and where the set point drops to 0, and then afterwards when the airflow begins to track to set point. For the trend view on the right, we found that a minimum ventilation set point had been incorrectly set, which was resulting in a low CFM. You can see again when this was corrected and the airflow began to track to set point. Deficiencies reports. This is a great example of a commissioning deficiency report that was generated by one of our partners using data pulled directly from Kaizen. You can see the headers for each column that include an ID, date, a finding name, description, recommended actions, notes and actions taken, as well as status. Most of the issues shown here are related to BAS data and networking issues, which are important to fix promptly as this delays the functional verification of systems. If you follow the workflow for the top row, you can see that the finding was related to a connectivity issue to the first floor terminal units. The description and recommended actions provide additional details and instruction. In this case, it was determined that the network communication for the first floor devices needed to be further investigated, and it was then noted under actions taken that they found a BAS network Ethernet cable had been removed. Now, onto the operations phase of commissioning. Here are some of the activities during this phase. Provide performance tracking and status reporting of outstanding commissioning items. Complete deferred functional testing. Identify opportunities to optimize systems, including fine-tuning control loops and adjusting schedules, sequences, and set points. Monitor, benchmark, and evaluate building energy performance, and establish an ongoing commissioning program. Derek, I'll go ahead and turn it back over to you to discuss the operations phase.
Thank you, Michael. All right, let's take a look at the operations phase and how analytics can be used for ongoing commissioning. What you're looking at here is the community library in Kaizen. This screen capture shows on the right-hand side a search field where users can come and search for sensor. When you search for sensor, the community library in Kaizen will list all rules that are sensor related. You can see on the top left, there are different insight categories in Kaizen. Energy key performance indicator, fault detection, which is what is selected in this screen capture. Then there is integrity key performance indicator rules, prioritization rules, etc. The idea of a community library is that users will be able to see and use rules authored by CopperTree, plus rules authored by our community of users, clients, and partners included. All of these rules are at your disposal. And when you search for a keyword like sensor, all of those rules will show up on the list. And then you can be more specific. For instance, Michael talked about haystack tags. That is an industry standard. And you may want haystack rules to be applied on your buildings because you are using haystack tags as part of the Kaizen implementation. Keep in mind, the implementation of the software can either be done by the controls vendor or it could be done by the user itself. And you need to make sure that when you opt for an analytics platform, those are all questions that you're considering. Highlighted here in red is a sample rule. Discharge air temperature sensor may be faulty. You can see the unit, it's degree Fahrenheit, and it's using haystack tags. The description says sensor validation rule, check for unreliable readings in range and quality. This rule is part of the CopperTree standard rule set. So the idea then is that the tags that Michael talked about, which have been added to discharge air temperature sensors in the building, will be used to map this rule to those sensors. And that can be done with the click of 2 buttons. It's not a manual process, and that's why tagging of points is such a key piece to analytics implementation. FDD Insights. So let's say the rule has been implemented. What is next? Well, the rule goes to work for you, and it generates insights or alerts or notifications whenever something of interest happens in the building. On the left-hand side, you're looking at an insight summary. The message says, discharge air temperature sensor is reading a constant value. Sensor may be faulty. What I really like here is the insight history, which is a newly added feature. At a very quick glance, you can see all of the days since when the rule was active. This is from the second week of November 2020 up until now. Throughout that time period, 2 weeks are highlighted in red, showing those are the times when this rule triggered insights, and the other days are highlighted in gray, meaning this was not an issue at that point. Think about your buildings with many more weeks of operation history, and you'll be able to use a view like this to quickly see patterns. Are these issues only happening during weekends, or is it happening weekdays and weekends included? Is it seasonal, or is it happening across the board, all months included? Those are all questions that can be answered in such a very simple view. On the right-hand side of your screen, you're looking at an example fault itself. This is a room temperature sensor. You can see that the room temperature sensor for this building, which is based in Seattle, again, this is a real-world practical example, it was always reading 32 degrees Fahrenheit. This was detected using the analytics platform and reported to the controls contractor. The controls contractor acted on it, and since then, the issue was fixed. On the right-hand side of that trend log viewer, you are able to see trends, the trend moving up and down, reading different room temperature readings. Again, within the community library, as commissioning professionals, you may be very interested in control tuning rules. Well, you can search for tuning. In this case, on the top left, you can see that integrity key performance indicator rule category has been highlighted. So just within that category, there are 4 different rule templates that are available. Building static pressure control requires tuning. Hydronic differential pressure control requires tuning, so that can be applied on hot water systems and chilled water systems. Supply air pressure and VAV supply airflow control related rules. Think about it this way. For your different equipment, air handling units, rooftop units, VAVs, fan coil units, unit ventilators, chilled water system, hot water system, name it, you are having multiple process variable control loops. For all of these control loops, you can use rules like this that will tell you how well the loops are tuned and if there is room for improvement. Now I want to talk about KPI reports or key performance indicator reports. Before I show you an example of a KPI report, I wanted to show another real-world example of a fault. This building data comes from a building in New York. It's a very prominent building. And what you're looking at is data from an AC unit, AC 25-1. What I'm interested in showing you here is the pink line, which is the sensor, static pressure sensor. The static pressure sensor reads negative values when the fan is off, which is what we detected. And when the fan is on, it reads a pressure sensor pressure reading. However, that reading is always really lower than what the actual pressure is. Now, what does this do? This tells the fan that the pressure is always below the active set point, causing the fan to ramp up to really high speeds. And we were noticing fans in this building running around 80 hertz. That's a lot of electricity consumption. And with the additional airflow, a lot of excessive thermal consumption as well. All because a pressure sensor is reading inaccurate readings. Now, this building, which is a high-rise, has 65 ACUs in the building, 1 ACU per floor. In the KPI reporting slide that I have here, I'm showing you how a KPI report was used to capture poor performing systems. The KPI score here indicates percentage of time when the fan was off and the pressure sensor readings recorded an error. It's an automated report that compares different ACs, showing worst performers and best performers. On the right-hand side, you can see the poor performers highlighted in red. AZ11 has a KPI score of 100%, meaning for 100% of the time, when the fan was off, the pressure sensor reading recorded an error. Same for AC51 and AC511. Now think about it this way. For this building, they may have limited resources who can fix these things. And you don't want your resources to go look at all 65 AC units when really you're only having issues with 6 of them or 7 of them. KPI reports like this allow you to be really targeted, making sure that your money, time, and resources are spent correctly. On the left-hand side of the screen, you're looking at some sample report types: zone temperature analysis, zone airflow analysis, supply air temperature control analysis, static pressure control, control valve, control damper, name it. You can set up reports for all of these and more. BAS Parameter Benchmarking. When you have a building that is considered fully commissioned, really what you're saying is everything is working as it should be, and you hand over the building to the building owner, the building occupants, or I should say the building facilities operators who take care of the occupants in the building. Now, what a feature like this, which is our golden standard feature, does is it always compares your new data with the golden standard, which is from a perfectly commissioned state, meaning new data each day from the building is compared with the good golden standard, the perfect commissioned state of the building. And whenever there is a change in object property values, the tool can trigger an insight saying, hey, for this particular controller, for this particular object, in this case, an AV, this particular property out of service, there is a change. What is the change? Well, the golden standard from 2019, May 11th, was that the out of service property was false, but now the out of service property is true. And all of a sudden, the change, in this case, a bad change, is flagged, alerted, and the building operator can take care of the issue. Think about the same tool which you can use to catch issues like this. Michael already talked about this, but again, this is a real world example where we noticed that the airflow set point was above max CFM. Controls contractor identified that the airflow set point was left in hand, and once it was fixed, you can see on the right-hand side, the airflow correctly tracking the set point. Let's look at opportunities for ongoing commissioning. In this section, I'd like to talk about energy performance reporting. We talked about EIS when we began the presentation. We'll talk about FDD, Fault Detection and Diagnostics, and system performance. This document, Ongoing Commissioning Best Practices, built by Building Commissioning Association, and I believe Jesse was involved in this document preparation. It says ongoing commissioning often incorporates processes such as monitoring-based commissioning, including technology-specific fault detection and diagnostics, energy management and information systems, and other performance tracking analytic solutions. All to say, there is FDD, there is EIS, there is EMIS, And these different tools work together to help the building owner at the end of the day. What you're looking at here is a screen capture from CopperTree's EIS tool, the Energy Information System tool. And we are trying to determine the baseline energy consumption for a building. It's a school building. You're looking at the electricity consumption in purple on the left-hand side of the screen. And the gray line is the baseline, which was calculated using an independent variable, heating degree days, which you can see on the right-hand side of your screen. That linear regression analysis was completed. The R-squared value was not very good, meaning it wasn't really following each other all that well. However, the results showed that there was a 7.77% reduction in energy consumption, which translated to close to $3,000 in cost savings. But is that the full picture? Let's take a deeper look. We then realized that the occupancy of the building was changing throughout last year because of COVID-19. And we added another independent variable to the analysis to determine the actual baseline. When we did that, we included carbon dioxide concentration, which is an implicit occupancy sensor data. If you have actual occupancy sensors in the building, great, you can use that. That's explicit occupancy sensor information. But if you don't have that sensor availability, you can use something like carbon dioxide concentration, which is a reflection of actual occupancy in the space. Now, when the second independent variable, in this case CO2, was used, we found that the actual energy consumption in the building is higher than the baseline. In fact, the actual consumption was 2.86% higher and close to $1,000 excessive energy consumption was happening. Why this example? It's just to communicate that EIS is an important component in commissioning, number one. Number two, you also need to make sure with COVID-19 and a post-pandemic world we are entering, HDD and CDD are no longer, or heating degree days and cooling degree days are no longer the independent variables that we should be using. Of course, they're a big part of it, but we now are entering a world where occupancy in buildings are fluctuating all the time. Mondays are less occupied than Wednesdays, and Fridays are less occupied than Thursdays. And changing occupancy has an impact on energy consumption. And so all of these parameters need to be included in a smart EIS tool that can do the job for you. Building FDD and performance issues. Now, after talking about all of these different phases in a commissioning project and different types of reports and insights that you can get from an analytics platform, I want to conclude by saying that it's very important that the results of the analytics platform are presented to you in a very easy to use manner. On this screen, you're looking at different insights from the building. On the left-hand side, you can see the priority associated with these insights, the system it's related to, the message, rule type, last occurrence, active state, or the current state showing active or inactive. And from here, the user should be able to say, well, indoor temperature issue, my temperature is outside of ASHRAE's temperature range. I want to assign this to operator A. And then operator A gets an email, let's say, when they are alerted about it, or when they log into the system, they should have it under their tasks list. They should be able to take a look at all of the trends and the recommendations coming from the analytics platform, start acting on that issue, change the status from open to in progress to closed eventually, add comments so that next time something similar happens, it may be a different operator or a different user looking at that issue, and they have all of that action summary. These are all very critical pieces to make sure that analytics, which is a platform as it gets introduced to the building operations, it should be easy for you so that we can take advantage of the good results from the platform and include it into the daily, weekly workflows of the real people using the building. And with that, it's over to you, Jesse, for Q&A.
Great, thank you, Derek and Michael. A great session there. Really appreciate the information. CopperTree's been a long-time engaged partner with the Building Commissioning Association, and looking forward to some of our Q&A here. So I'd ask our attendees to feel free to use that Q&A option at the bottom of the screen there, and we'll address the questions as they come up. Derek and Michael, I did want to just key in on a couple things and talk through a couple points with you. One's more of a comment. You know, I did very much appreciate the tie back to the ongoing commissioning best practices and you know, the session overall, thinking about monitoring based commissioning, not just as a tool that's synonymous with the approach for ongoing commissioning, but also thinking about, you know, fault detection and analytics as a really valuable asset for new construction and existing building commissioning, which I think is becoming more and more commonplace in our industry today. Question, and maybe one thing that I'd like to dive a little bit deeper in with you, Michael, you mentioned the common frustration with point mapping and getting the system up and running. And you know, there's definitely cases where you can come across a properly tagged building using more industry standards and Haystack, but I think what we find more often than not, especially with existing buildings, is a lack of standardization. And just, you know, wanted to get a little bit more thoughts from both of you on, you know, how do you overcome this challenge? You know, when you get to that building or portfolio that it's just all over the place. And you know, I appreciate some of the automation that you've got, but when that doesn't work, what's the next step? How do you fix that? How do you get this up and running?
Are you taking that one,
certainly. Oh. Yeah, absolutely, Michael. I wasn't sure if you were going to jump on, but great. Let me start getting going on this. We often come across buildings like this, and the first step is to see if our AI platform can look at what's being derived from the BAS and tag the points appropriately. And if it does, that's great. But that may not be the case all the time, in which case we actually rely on actual human beings to look at the data and apply the right tags. And it could be a combination where we use the platform to assign tags appropriately, and then our staff, you know, we have got building application engineers who take a look at the actual data set and then apply tags. So it could be a combination of the two. Now, that may resolve the issue for the short term. Sometimes it can be very extensive where, you know, you may have to do some point-to-point verification because the naming infrastructure is just that bad, and there is lots of work that's involved. Now, that issue can be fixed in the short term by going through this process, and we get that all done on real projects. But we don't stop there, and we shouldn't either, because this building owner may have 20 other buildings that are being constructed right now. And it's important to let them know that standardization is key and that they need to work with their controls contractor to make sure that points are named correctly. So we have to fix the temporary issue, and then we have to make sure that new projects, new buildings that are being constructed have a plan moving forward. And CopperTree has put together a naming convention standardization document that we often share with our customers and say, hey, you know, this is done, you know, we've done the best we can here, but when you have a recommissioning effort, when you are, you know, when your controls contractor is coming back and redoing some work, keep this in mind. Plus, for any of your newer projects, make sure that you take advantage of the standardization document and do it appropriately.
I appreciate that approach, Derek. I think that makes a lot of sense, and I am looking forward to more standardization and point mapping in our projects for sure. We do have a couple questions here, more about the platform flexibility and in particular about the analytics rules. And, you know, can you talk a little bit more about how flexible they are and who can make changes, or if it's possible to make changes to the analytics, and with that too,
Yeah.
talk a little bit about, what's the focus? We talked a lot about HVAC examples, but can you talk also about how you can apply these to other systems as well?
Yeah, absolutely. It's a brilliant question. I believe that an analytics platform should be flexible enough for users to make changes to it. I'll give you a very quick example. We work with hospitals quite a lot, and many of you on this webinar may have worked on hospital projects, which are very different from office spaces. The controls that are required, the spaces that are of interest, like OR rooms, are critical, and we need to make sure that the thresholds for these rules, looking at an OR room, is very different from the thresholds that are used in a rule looking at a conference room in an office space. And when it comes to rules implementation, CopperTree's approach is we use default ratings. So for instance, humidity, we look at humidity asterisk acceptable levels, so 30 to 60%, let's say, and that's the lower limit and the high limit. And we use that as the default, and our customers know where those numbers are coming from. Those rules are implemented. Saying that, though, it doesn't mean that those inputs cannot be changed. We run into buildings a lot where our user may look at that and go, you know what, your high limit of 60% relative humidity, I don't really like that. For my building, I want to be 70%. And we make sure that it's easily adjustable for the customer. Either CopperTree can do that for them, or the customer can do it for themselves, because it's a simple, 2 clicks of a button change. And when you change that, again, keep in mind, it's important for that rule that you just changed to be applied on the historic data plus any new data. Because you may want to know, tell me the number of hours when my relative humidity was above 70% historically. And so that's one answer with respect to who can make changes, are changes practical, etc. Now, on the other hand, there are different types of rules. And I want to emphasize on health compliance today, if at all I can. And the reason I bring up health compliance is because of COVID-19 and some of the changes that we have seen in buildings. When people talk about analytics right off the bat, everyone is like, let's save some energy, which is great, we should. But with what's going on, there is an even more emphasis on complying to standards that are put in place. And it's important to make sure that when you're looking at your building, you're not just looking at energy savings, that you're looking at energy savings and occupant comfort and the compliance reporting. What is it that you can implement that will give you all of this? Because one is not above the other. I would argue that safety is more important than energy, but as time goes on, you need to save energy as well. And you need to have that proper balance. And we now released very recently health compliance rules, which look at building operations in a different way. Are your purge modes on air handling units working correctly? Are your temperatures within range? Are your humidity levels within range? Because humidity affects virus spread. And that's one of the latest Yale studies that I looked at clearly talks about how relative humidity in spaces affect virus spread. So these are different, things that we need to be looking at. And a smart analytics engine should be able to take care of not just energy, but occupant comfort, safety, ventilation, et cetera, et cetera.
Thanks, Derek. I think time for a couple more questions here. There was one question someone was asking about if a copy of the presentation could be provided. And if anyone does want a copy of the slides, please put your email address in the Q&A, and Michael and Derek can follow up with an email to you with a copy. And then as a reminder too, the session is being recorded and would be available to anyone in the future as well. So with that, maybe one last question here. And there's a couple people that are asking a little bit more along the lines of the value. And from a person that's trying to create the business case and get clients and stakeholders engaged in the value of monitoring-based commissioning and analytics, as well as what we're trying to shoot for from a success factor and what we're trying to get to from an outcomes. Can you talk a little bit more about how do you make that initial value pitch, and what are the success factors that you say really indicate the successful projects out there?
Yeah, before I give you my answer, I would definitely direct our viewers to one of the recently published articles from LBNL, Lawrence Berkeley National Laboratories. And they basically look at different analytics products out there and have provided a very good analysis of how much energy can you save, how much improvements can you make when you apply these analytic solutions on your buildings. And I think that's a great document to refer to so that you can get some generic numbers, not just from CopperTree really, but from all of these tools that are out there in the market. Now, when we approach a customer and we talk about analytics, at the very least, we talk about these points. Number one, reduction in energy consumption. And our payback usually is in a matter of weeks. We're not talking about a year, 1 year payback. We can actually give you a payback in just weeks. And that's because most buildings have lots of opportunities that can be taken advantage of to reduce consumption. Number two, we talk about reduction in maintenance hours. And that's key. We talked about the key performance indicator rules where, if you have a building with 400 VAVs, I know buildings where controls contractor goes in or maintenance team goes in once every quarter, looks at 100 boxes this quarter, next quarter, they look at the next 100 VAV boxes, so on and so forth. Gone are the days when we should be doing that. That's a lot of money and effort. We should be taking advantage of an analytics tool that says, you know what, run these rules, show the worst performing systems. Don't even bother to go look at those VAVs that are doing just fine. It's just a waste of our time. Let's go fix those boxes that aren't doing all that well. And what does that do for you? Reduces your labor hours, saves you time, which is an important commodity so that your time can be spent elsewhere, saves you money. And that's two. Number three, with COVID-19, I'll re-emphasize comfort and safety. And reporting on how well you're maintaining comfort and safety. Those are three things I'll add right off the bat. And then there is this picture that I can't forget, which is buildings are great when they're commissioned and you hand it over to the customer, come back a year later, you know how it is. And there are multiple things that happen. And an analytics tool makes sure that you're always closer to that standard or in that golden standard state, as opposed to all of these changes happening and buildings going haywire.
No, that makes perfect sense, Derek. And sometimes the best sales opportunity is a year after you do the commissioning, just to your point there.
Exactly.
Yeah. Derek, Michael, I want to say thank you again to you and to CopperTree Analytics, and very much enjoyed your session. Thank you to our attendees for your time today. Hope everyone has a great day. Thank you.
Thank you, everyone.